All right, so we've worked through the first part of special segments in a circle, and it's very straightforward. You multiply the segments and make one segment equal to the other because their products are congruent. Um, we're going to do the same thing, only unfortunately, we're going to have uh, a problem because we're going to have a quadratic equation, or we're going to have something that we need to factor, and I need to remind you how to do that first and foremost. So I'm going to take one simple quadratic equation, I'm going to factor it out the way you already know how, or hopefully you already know how. If not, you're going to have to get some information on the internet, or maybe I'll post some videos later on how to do that. But I want to look at something simple. A quadratic equation is simply an equation that has an x squared term plus an x term plus or minus an x term plus or minus some sort of constant that equals 0. And so ignoring the circle here, I'm just going to show you something simple. X squared plus, let's say, 4x plus, let's make it real simple, 3 equals 0. Here's a quadratic equation right here, and there are ways to do it. There's a quadratic formula, which everybody hates, negative b plus or minus the square root of b squared minus 4ac divided by 2a. Nobody really likes it, but it's really valid. It helps us out. And so I'm gonna solve this one, and we're gonna take a look at how it works. I'm gonna look at these two terms on the outside, right? First, I'm gonna look at the lead term, that x squared term. How do I get x squared? By multiplying, right? And all I'm doing is undoing that multiplication. Well, how do I get x squared? What do I multiply by itself to get x squared? And we know that that's x. So you create two sets of parentheses, and you can put the equal 0 out there. And you know that the first term in both of these, when we FOIL, remember FOIL, had to be x, okay? And then you take a look at the operation symbols inside, okay? So your next step is to look at the addition symbols. You look at this one first, this last term. Is it positive or is it negative? If it's positive, then both of the operation symbols inside are going to be exactly the same. All right? And then you look over here, and it's going to tell you whether those two same things are going to be positive or negative. And you know that they're going to be positive because that's an addition sign. So you're going to put in your addition signs. And then you're going to do the last bit of work. You're going to say, what two numbers do I multiply together to get 3? Well, there are only two factors of 3. It's just 3 times 1. It's the only way you can get 3. So we take a look at that and we say, okay, 3 times 1. Okay, but what if I added them together? 3 plus 1 equals 4, and it does match the 4 that's in the middle. Okay, so I know you haven't done this for a while. It's been a while since you've been doing a lot of algebra, but this is what you have to do with the most difficult parts of this segments in a circle piece. So now you have x plus 3 and x plus 1 equals 0. Now, you take each of these sets, all right, so you're going to say x plus 3 equals 0 and solve for x, and then you're going to do the same thing with x plus 1 equals 0. You're going to solve that, and you're going to find out what x is, okay? And that's finding roots, finding the roots of a quadratic equation. When we have a parabola, it tells us where it crosses the x-axis. And you would just say, okay, minus 3 on both sides, and that gets rid of that. So x is equal to negative 3. And do the same thing here, minus 1 and minus 1. And x would be equal to negative 1. So this particular parabola crosses the x-axis and at negative 3 and negative 1. And that's okay. You don't have to worry too much about that right now. We're just taking a look at this and talking about solutions. Now, I'm going to do one that's a little bit more difficult because it's going to have addition here, but it's going to have subtraction here. Because what you're going to see when you do this is something that looks like this. Okay. 45. Okay. So x squared plus 4x equals 45. Now we can't solve this because we have this squared term and we have an x term, so we have to turn it into a quadratic equation. And you're going to have that when we go through this momentarily, but I wanted to show you how it's done first, and then I'll do it with this particular example, and then we'll go move on with our lives. All right? So what we want to do is make this entire thing equal to 0 so we can factor. So just subtract 45 from both sides, and now we have our quadratic equation minus 45 equals 0. We want this to equal 0, and I know you're used to solving one or two step equations, and you're always wanting to put your constants on that side and your x values on this side. But for these types of examples, or for this type of example, when you end up with an x squared term, and you can't just take the square root, because sometimes you'll be allowed to take the square root, I need you to know that you have to set up this quadratic equation and then factor. Now we can factor this, and we know we're going to set up our parentheses again. And then we're going to look at the lead term first, and we know that x times x gives you x squared. Now we're going to look at this symbol here, and this symbol here is subtraction. And the only way to multiply two different values and get a negative is to multiply a positive and a negative. So we know for a fact that there's going to be one addition symbol and one subtraction symbol. And if you need to go back and listen to me say that again, please stop the video, go back a little bit, and have me say that again. If this is negative, then inside these parentheses has to be one of each operation symbol. Okay? And now, here's the most difficult part of the whole darn thing. What factors of 45 are there? All right? So we know 45 is 15 times 3. So let's write it out here. 15 times 3. 45 times 1, but that's not really going to help us too much. And let's say 9 and 5. And I don't think I know of any other, no other cool factors that will give me 45 that I know off the top of my head. And I'm going to look at 15 times 3, and I'm going to say, okay, I have an addition and a subtraction symbol here. So I'm going to have to find a difference between these two factors that will give me a 4. Okay? So 1 minus the other gives me 4. 15 minus 3, does that give me 4? No. 15 minus 3 is 12. So it wouldn't work in here if we had to multiply this out. And so I'm just reminding you. So we don't use 15 and 3. We're going to use 9 and 5, right? So 9 minus 5 is 4, right? We want the 9 to be next to the addition symbol or the positive symbol, because we want positive 9 minus 5, because 9 minus 5 gives me positive 4, and I have a positive 4 right here. So I'm going to put my 9 next to the addition symbol, and I'm going to put my 5 next to the subtraction symbol. Now I can honestly say that if I multiplied everything the way I'm supposed to, right? Remember, we FOIL with this. It's firsts, outsides, insides, and the lasts, right? That's how we FOIL. So we would multiply x times x and we'd get x squared. We'd multiply 9 times x and we'd get positive 9x. And then we'd start, oh, darn, I made a mistake. We do the outsides next, right? X times minus 5 is minus 5x. Then we do the insides, plus 9x. And then positive 9 times negative 5 is negative 45. All right? And then we would put the middles together because these are like terms. It's a constant and an x and a constant and an x. And minus 5 plus 9 is plus 4x. And that's how we got there. All right? We're back to where we started. That's what FOILing is. And this exercise that we're doing is undoing it. It's called factoring. And if you don't know about factoring, there are lots and lots of videos to help you through it. But this is important because there are a couple of examples where you'll have to undo or unfoil or factor, as it were. Now, like I did in the previous example, I'm going to take each set that's in parentheses and I'm going to make them equal to 0, and I'm going to solve for x. So x plus 9 equals 0, and x minus 5 equals 0. And I'm going to do the math. I'm going to subtract 9 from both sides. That goes away, and we have a negative 9. So x has a value of negative 9 here. And then I'm going to add 5 to both sides, because this is minus 5 plus 5. They cancel each other out. That equals 0. And 0 plus 5 is positive 5. So I have a negative value and a positive value, and this is the single most important thing when you factor. When you have line segments or actual distances that you're calculating, there's no such thing as negative distance. Okay? So when you're calculating how far something is, if you have an x, this can't be negative. It can't be negative. Now this x might be able to be negative if this plus were very, very, very large, or this addition, this constant that we're adding to it were very, very large. We could subtract a little bit from it. But you can't have a negative distance. It can't go into dark matter. It can't not exist anymore. So we would just say the negative value doesn't work for us, so the positive value has to be our answer. And really and truly, that's, that would be a 5, and then we would do the math with that once we have that. So now, because this is going to be a super long video, I'm going to do this example that I have now that I've shown you how to do this. So we know, because this was the first set, that the product of this is going to be equal to the product of this. This whole line here and this whole line here. The product of the two segments is going to be equal to the product of these two segments. So I'm going to do the product of these two segments on this side. X times x plus 5 equals 3 times 8. Okay, so far so good. We've written it all out, and we can do this math, and everybody knows that 3 times 8 is 24. That's the easy part. And then we're going to distribute the x. We're going to multiply the x by every piece inside the parentheses, and we're going to get x times x, which is x squared, and then x times 5, keeping the addition symbol, is 5x. Well, now we're getting to something we just saw, right? I just set this up this way so that we could see it again. And I want this whole thing, since I see a quadratic, I see a square term, and I see an x term, and I can't undo that. I can't make sure that I find a value that satisfies both these, because this would be a square root, and it doesn't work. Okay, the square root of x with an x term would really mess us up. So I'm going to solve this for 0. I'm going to move my 24 by subtracting 24 on both sides, right? And that goes away, and that becomes 0. So now I have my quadratic, because I have x squared plus 5x, and I can't subtract 24 from 5x because there's no x term. It's not a like term, so I'm just going to leave it on the back side. This is now our constant, okay? And we have a lot of great stuff here that can tell us what's going on. This right here tells us what's going on and how this works out. The 8 and the 3 are already giving us a clue as to how this is going to work out. And so I'm going to set up my parentheses equal to 0. I know it's going to be both addition and subtraction, and I know that x times x is x squared. Now, what I'm going to do here is I already know my factors that give me 5 because they're written right here. I'm not going to try 6 and 4 because 6 minus 4 is 2. I'm not going to try 12 and 2 because 12 minus 2 is 10, and that's not a 10. I mean, there are all these factors of 24, right? 6 and 4, 12 and 2, and then last but certainly not least, 8 times 3, right? These are the factors. 8 times 3, well, if I subtract 3 from 8, I get 5, so I know I'm good. And I need it to be positive, so I need my larger value next to the addition symbol. And 3. So if you have trouble with this, I'm gonna allow you to stop here when you get to this guy or you get to that guy. I'm going to allow you to stop there, but eventually you should learn how to factor these things. And last but certainly not least, I want you to see that these segments are actually congruent just by looking at them. But we're also going to have to solve. X plus 8 equals 0, and x minus 3 equals 0. And so we subtract 8 from both sides. So x equals negative 8, and we add 3 to both sides, and x would have to equal 3. Now, can we have a negative distance? No, we can't have a negative distance, so we're going to have to go with the positive 3. So if we make x equal to 3, let's put it in and see if this works out. 3 plus 5 is 8, so 8 times 3 is the same as 8 times 3. Oh my gosh, they're exactly the same. Now the one on your worksheet doesn't work out as pretty as this does. I just sort of did this so I could show you how to get through it. I know it's long and I know it's difficult, but these are very, very important skills to have in terms of algebra and mathematics. So good luck on this one. If you need more help, let me know. I'll put up some quadratics and we can factor them out together, or just take a look at some videos online. Khan Academy shows you how. There's some other math guys that show you how to do it, and they do it very well.